Hi students, in this video we are going to solve few problems basing on spring block system, means how to calculate time period. Let us see first one, find time period of oscillations of the block in the figure given. You can see diagram here. Spring is connected to a block of mass m, spring constant is k, assuming spring is massless, pulley is also massless. Okay. And we have discussed earlier one important point, that is, whenever you want to calculate time period in case of a spring and block, there we can assume there is no gravity because time period is not depending on gravitational force. So let us assume here there is no gravitational force, means no gravity. Now focus block of mass m. So initially on the block, since no gravitational force, no tension, that means the spring is in its natural state. So tension initially equal to zero because no gravity. Therefore, no spring force. Initially, no spring force. That means it is in its natural state initially. That means when block was in equilibrium position, no tension. That's why no spring force. No spring force means spring is in its natural state. Now displace the block from its mean position by a distance x downwards. Displace the block from its mean position by a distance x. Now we have to focus what is the restoring force. Okay. So here you can see block is connected to only string. That means tension in the string becomes a restoring force. Initially that tension was zero. Now see what is the tension. If block is moved down by x distance, spring also elongates by x only. See carefully. If block is coming down by x distance, spring elongates by x distance because in this pulley is fixed. We can see here the string length is a constant. Okay. So pulley is not moving. If a block moves down by x distance means spring elongates by x distance. Okay. That means in the string tension is equal to kx. I am writing here. In the string tension equal to kx. And if you want to write more accurately, tension equal to minus kx. Why minus means block has displacement downwards, but tension is upwards. I am repeating, block has displaced downwards. That means direction of displacement downwards, but tension on the block, it is upwards. Directions are opposite. So tension equal to minus k into x. So here tension is nothing but restoring force, which is in the form minus k into x. That means in this problem, spring constant is nothing but force constant. I am repeating, in this, spring constant is nothing but force constant. That's why time period equal to 2 pi root m by k. Okay, right. Now let us see the next question, question number 9. Read the question carefully. See diagram carefully. It is now slightly different from the previous problem. So again, here also we assume there is no gravity because time period is not depending on gravitational force. I have written here. While calculating the time period in spring block, we can take G equal to 0 because time period is not depending on G. So in mean position, spring is in its natural state. Okay, right. That means if you are focusing the block, initially no tension, no spring force, and as usual we have taken G value 0, no gravitational force. Let us take block is now displaced by distance x down. Consider block is now displaced by distance x down. Now focus what is the restoring force. Again, here you can see block has a connection with the string. That means now again tension becomes a restoring force. Okay. That means now we have to calculate that tension. How much? Now see carefully. Suppose the tension is T here. Now here also tension is T. So tension T here. And here also tension T. When tension T and tension T in spring, that force will be 2G. Right. And here one more thing. If block moves down by x distance, pulley moves down by x by 2. I am writing here. Pulley moves by x by 2. This is a pulley. Okay. When block moves down by distance x, pulley comes down by x by 2. Pulley comes down by x by 2 means spring elongates by x by 2. I am repeating. If pulley comes down by x by 2, then spring elongates by x by 2. That means now spring force will be, it is a k into x by 2. I am writing here free ball diagram. See carefully. On the pulley, see how many forces acting. Tension downwards. Now here also tension T downwards because tension is always pulling force. Next coming to your spring force, that is upwards, which is equal to k x by 2. And since we have taken pulley is massless, on the pulley net force must be equal to 0. That means 2T is equal to kx by 2. I am writing here 2T is equal to kx by 2. Okay. Therefore, T equal to, it is a k by 4 into x. Okay. And again here also x is downwards but tension is upwards. So we should write here minus. Okay. There you can write minus, which indicates direction part. Okay. That means restoring force in the form some constant into x. That means in the place of a force constant, we are having now k by 4. I am repeating. In the place of a force constant, we are having here k by 4. Okay, that's why now time period becomes T equal to 2 pi root m by force constant, that is k by 4. Okay, that means we are calculating in this problem what is a force constant, that is a k by 4. Therefore time period is 2 pi root m by k by 4, that is the here answer, 2 pi root of 4m by k. Okay, let us take one more problem. See diagram carefully. So find time period of oscillations of the block. So here block is oscillating and motion of the block is simple harmonic. So we have to calculate time period of oscillations of the block. So again here we are taking the assumption that there is no gravity, therefore no gravitational force, no tension, no elongation of the spring. So spring is in its natural state. So in mean position, spring is in natural state. Okay, right. So first step is displace the block. Displace the block by a distance x. So when we displace the block from mean position, then we have to calculate what is restoring force. Okay, I am drawing here free body diagram for the block. So for the block free body diagram, downward no gravity. So we have taken block is connected to string, so tension, that is T, which we have to calculate. Let us consider block is displaced downwards by a distance x. Displace it by a distance x downwards. So when we displace the block x downwards, pulley also moves down x because pulley connected to string. Okay, so block moves down x means pulley also moves x downwards. When pulley moves x downwards, spring elongates, it is by 2x. You have to focus carefully here. When pulley moves down by x distance, spring elongates by distance 2x. Okay. Now draw free body diagram for the pulley. So taking FBD for pulley. FBD for pulley. Tension T downwards. Okay. Next coming to here. Spring force K into 2x. And here also K into 2x. You can see here this string is connected to this spring. That's why throughout this force must be same. Okay. Now sum of these two should balance tension. Why they have to balance means because we have taken pulley is massless. Therefore, net force on the pulley should be zero. So I'm writing here tension T should be equal to, it is a K into 2x, K into 2x, it is a 4K into x. And if you want to include direction part, then you can write here minus, because block has displaced downwards, but tension is upwards. So direction of tension and displacement, they are opposite. And you can see here in the place of force constant we have, it is 4k. So restoring force equal to force constant into x. Therefore time period is t equal to 2 pi root m by force constant, that is a 4k force constant. Okay, that is now time period. That is what we have written here, right? 2 pi root of m by 4k. Like this, we can solve time period by assuming there is no gravity, which helps us to simplify, or you can say, make the calculation part more easy. We can solve same questions by using gravity also, means by taking gravity, but a calculation is little bit lengthy compared to this one. Okay, students.